You know, some of the universe's biggest secrets aren't tucked away in the darkest corners of space. Nope, they're actually hiding in plain sight, inside some of the brightest things we can see in the night sky. And they're flashing with a rhythm so precise it could put our best atomic clocks to shame. So let's take a trip to a place where these cosmic clocks are ticking away. So where are we headed? To a place astronomers call Messier 5, or just M5 for short. And I want you to think of it less like a simple cluster of stars, and more like a massive, ancient, and unbelievably crowded city of stars.
And here it is. Just take a look at that. What you're seeing is a real X-ray image of M5. It's what's known as a globular cluster, basically a giant spherical ball of hundreds of thousands of really old stars, all packed together by gravity. It's one of the most ancient structures in our galaxy.
And to give you a sense of just how far away this is, M5 is about 24,000 light-years from us here on Earth. That means the light hitting our telescopes tonight actually left that star city way back when our ancestors were living in the Stone Age. It's a journey through time just as much as it is through space. And you have to understand this is not a peaceful, quiet neighborhood of stars. M5 is extreme. The core of this star city is thousands of times more crowded than the space around our own sun. It's like a cosmic mosh pit, a perfect place for stars to interact in some really wild ways we just don't see out here.
So what happens when you cram that many stars together for that long? Well, all that chaos forges some seriously strange and exotic objects. Hidden deep inside that city of stars are these tiny, spinning beacons that scientists have been trying to figure out for decades. They're called pulsars. So what exactly is a pulsar? Well, imagine a really big star dies in a huge explosion. Sometimes it leaves behind this super dense core, a neutron star. And if that core is spinning and has a magnetic field, it shoots out beams of radio waves from its poles. As it spins, those beams sweep across space, just like the light from a cosmic lighthouse. But here's where it gets really interesting. The pulsars in a place like M5 are special. In that stellar mosh pit, an old, dead neutron star can actually get a second life. If it gets close enough to another star, it turns into a kind of cosmic vampire, pulling material off its neighbor. All that new material spins it up to absolutely insane speeds. We're talking hundreds of times a second, and brings it back from the dead as what we call a millisecond pulsar.
And this is what that lighthouse beam actually looks like to a radio telescope. It's not a flash of visible light. It's this incredibly sharp spike in radio waves. Every single one of those spikes is like a tick from that cosmic clock, arriving with almost perfect regularity.
So, how in the world do you study something so tiny and so mind-bogglingly far away? Well, you listen. You listen very, very carefully, and for a very, very long time.
And when I say a long time, I am not kidding. This is a real testament to scientific patience. Astronomers started listening in on M5 with the legendary Arecibo telescope way back in 1989. More recently, the enormous FAST telescope in China has joined the hunt. And by putting all that data together, scientists now have an incredible 34-year-long record of these cosmic heartbeats. Just think about that for a second. 34 years of listening to the whispers from a city of stars.
This whole process has a name. It's called pulsar timing, and the idea is pretty straightforward. Imagine you have a perfect clock out in space. Your job is to listen for every single tick and write down exactly when it arrives. Now, if a tick shows up just a tiny bit early, or a little bit late, that tiny imperfection tells you something is going on. Maybe something is pulling on the clock, maybe it's wobbling. It's a clue. Okay, so this chart might just look like a messy squiggle, right? But for an astronomer, this is a treasure map. This shows the difference between when a pulse should have arrived and when it actually did. And we are talking about differences measured in millionths of a second. But buried in that squiggle is everything. Scientists can see the wobble of an orbit, the gravitational tug of a companion star, and maybe even the stretching and squeezing of space-time itself. It's incredible.
So, after 34 years of this painstaking work, what's the payoff? Well, we now have a fascinating family portrait of the 7 known pulsars in M5. And let me tell you, a couple of them are real characters.
So first up, let's meet the new kid on the block, a pulsar called M5A-G, which was found thanks to the new FAST telescope. And this one's not exactly a friendly neighbor. In fact, it's what astronomers have nicknamed a black widow. So what in the world is a black widow pulsar? Well, it's pretty much as menacing as it sounds. It's a pulsar that's in a super tight orbit with a small companion star. But instead of being a nice partner, the pulsar is blasting its companion with intense radiation, literally stripping it away layer by layer. It's an energy vampire, slowly consuming its partner to keep itself spinning fast. And just get a load of these numbers. M5G is spinning 363 times every single second. That's way faster than a kitchen blender. It orbits its poor little companion star in just 2.7 hours, and that companion has been worn down to only about 2% of our sun's mass. This is just a completely extreme system.
But M5G, the Black Widow, isn't the only star of the show here. Let's meet another one, M5B. This pulsar is the heavyweight champion of the cluster, and it's pushing our whole understanding of physics right to the edge.
So how do you weigh a star that's 24,000 light-years away? You don't put it on a scale, you watch it dance. By measuring the tiny wobble in M5B's orbit, which is actually an effect predicted by Einstein's theory of general relativity, you can figure out the mass of the whole system. This chart is kind of like a cosmic police lineup, showing all the possible mass combinations that fit the data. And the result is astounding. M5B tips the scales at almost exactly twice the mass of our own sun. That officially puts it among the most massive neutron stars we have ever found. Now try to picture this. All of that mass, twice the mass of the sun, is crammed into a ball that's only about the size of a city. It's so dense that a single teaspoon of it would weigh more than Mount Everest. Just wow.
Okay, so we've found a cosmic vampire and a super heavyweight champion. That's pretty cool, right? But you might be wondering, so what? Why does any of this matter? What can these tiny, distant spinning clocks actually teach us about how the universe works?
Well, it turns out these pulsars are so much more than just cosmic curiosities. They are one-of-a-kind laboratories. Heavyweights like M5B push our theories to the absolute limit. They help us answer the question, how dense can matter get before it just gives up and collapses into a black hole? The whole M5 family gives us a front-row seat to see how stars live and die in these crazy, crowded environments. And their amazing clock-like precision gives us one of our best tools for testing Einstein's theory of gravity under conditions we could never, ever create on Earth. You know, this whole 34-year-long project has just been incredible. It's revealed so much. But maybe the most exciting part is that they're still listening. Those cosmic lighthouses have been ticking away for billions of years. And it just makes you wonder, what other secrets are they waiting to tell us?